I've been working for 3 years on a project called Chrysalis. It's a plugin for CRYENGINE 5 written in C++11 that provides a foundation of the features required to create action RPG style games. It's under constant development. Currently, most of the work needed for a walking simulator is complete or underway. Chrysalis is an open source project and is intended to be useful for study of the CRYENGINE or as a basis for your own RPG project. The primary goal is to provide the base functionality required by several types of games. Main focus is on making an action RPG toolkit, but there are several goals and steps along the way. While the primary goal is to make an action RPG style game, including weapons and combat, vehicles, and the usual sort of tropes, the first step to getting there is to make a walking simulator. So we'll require first and third person cameras, some input handling, an actor or a character system. The characters obviously need locomotion so that they can walk around. And then we'll need some sort of interactivity with door switches, puzzle items, all that sort of thing. And then on top of that, we'll need an item and equipment system because it's not an adventure if you haven't got a compass, a knife, and a torch. Well, the minimum acceptable product would be to have a walking simulator with just walking along the ground and probably jump and run, crouch. It would be nice to add some stretch goals of adding ladders, swimming, climbing, that sort of thing. It's worth spending a moment to mention that the code is in flux, and since I'm learning on the fly as I develop the code, a lot of things aren't going to be done as well as they possibly could. There are going to be features that are half-formed, there's going to be code that could be extended in many ways or could be improved or made a little more elegant, but I simply won't have time to deal with that while I go on to the next thing, or I simply won't have the information available to make it work as smoothly as possible. That's just the cost of entry. All the code is hosted on GitHub. So if you simply go to that repo there, and you'll be able to pull down any of the branches. I suggest if you're looking at the code that you look at the Ivan branch. I periodically delete that branch and merge it into develop or master, but all the current work is done on the Ivan branch. You can check that out to a folder and add it as a project into CRYENGINE, and it should just start up and allow you to sort of look at a test level or two of mine without any other fuss. When you're first getting started with a project, it's important to read the README documentation. It's going to document a few things that are a little bit different about this game, and important information on some things that are a little bit broken or need a little more attention than you might expect. Just go in there, give it a bit of a read. It's not too long and it's pretty easy to set up. Let's just jump in and have a quick look at the state of affairs so far. So the assumption is that you've booked the code out and that you've loaded up and are able to sort of start up from Visual Studio. You're not going to get very far if you can't do C++ and handle projects in Visual Studio. So, got a test level where I do all my work. Since I'm a programmer, the test level looks pretty uninspired. But here we can see two of the Modus characters. I bought the Modus basic pack to give me some characters so I could run them around. And I've got a few test objects. That's to test the DRS system, which is the dynamic response system. These are supposed to be flashlights, but I've switched out their graphics with books without any textures, which is because I suck at art. So let's see what we got. If we jump into game, we've got, well, it's a character. He's in first person view, but if you scroll your mouse, you can scroll your camera in and out. You can walk around like so. He can walk in any of the basic directions. He can go for a little bit of a jog. He's got a proxy, so he's not going to run into that. And of course, he can sprint any direction. Walk, jog, sprint. And recently I added the crouch animations. So now if you're looking carefully, you'll see that the camera is actually attached to a bone in his head. It's very easy to add this. So even if your character model doesn't support the bone name, you can add it using the attachment system. Now, recently I added a little bit of extra code, which will hopefully, on this demo, when I click on that other character, I'm going to click the left mouse button, it's supposed to do an interaction with them, and I've also set up to test a cooperative animation. These are the sort of animations you see when you slip up behind someone in the game and knife them to death. Of course I don't have those animations, so they're going to do something spectacularly boring instead. If it even works. There we go. I turned 45 degrees. The other guy didn't even do anything. It's a little bit iffy at the moment, but it may work. If you have a very clear screen, you should be able to see the mannequin test information is on the screen. You should see, there we go, it throws it in cooperative animation, cooperative fragment starts up, and then I start playing the interactive fragment. Like so. So that's kind of working. It doesn't work yet if you just do it with like a plain entity. The other entity needs to be an actor at the moment. It's got to have its own action controller. Now, there was a little bit of work done in trying to interact with various objects. Just very basically, just wanted to test if you clicked an object, maybe you could spin it around a bit and then possibly throw it on the ground again. There's nothing too exciting happening there. And of course, if you've got a doorway, well, you can just walk through it if you haven't bothered to put a proxy on it, and I haven't. But should be able to go up to the doorway and click on it, and because it's mostly test animations at the moment, it's actually firing off my turn 45 degree animation. That's a secondary thing. I'm firing it all off on this piece of code here. Doing that and that. Obviously I'd only do one of them at a time normally. But you can see that it's sending a little bit of information to the door entity and requesting it to play an animation. In this case, opening and or closing. It's going to toggle between those two states. Chrysalis has quite a long history. I started initially by looking at the game SDK code, which is a nightmare. And I spent many months trying to study and understand the code. And I realized that as I was trying to add new cameras to the code, that there were so many inbuilt assumptions and so many particular ways of doing things in that particular code base that it was almost impossible for me to add a new camera system to it. I got like 99% of the way through, but there was a couple of last steps and I just couldn't make them happen. At that point I decided to abandon Game SDK as it was just too locked down and look into another project. Somebody had ripped out all the minimum amount of code that you needed. He called it the blank project, I think. The very minimum amount of code needed to make CRYENGINE boot up and recognize your project as, you know, a viable DLL. Now I took that code and I looked at it, understood each line that I could, and wrote a comment for it so that it was clear in my head, and when I go back to it later I can understand what's going on if I've forgotten in the meantime. At some point along the way, the Game 0 code came out, and that added a few new nice features and, you know, cleaned up a few features of the code. And so I ripped all the guts out of the Game 0 that was useful and put that into Chrysalis. So Chrysalis was now a bit of a Frankenstein project. Sometime later, they come along with the blank C++ templates. And again, I looked at the templates, and the templates were doing things a lot better in many places. And I ripped out whatever was useful from the templates and put it into Chrysalis, which is now a lurching demon sort of, you know, Frankenstein thing. It's all sorts of bits of code from all sorts of places. It's got bits of Game SDK, Game 0, the C++ templates, and of course, project from scratch. Because of its long history, Chrysalis does have some craft, and it's had to pull in a few things from Game SDK. There were things that just couldn't be untangled. And so, for instance, you're going to see most of it right down here in the utility section. These are the sort of things that were, you know, they had sections of code depending on them, and there wasn't an easy way to detangle it. So, you know, item string, for instance, it's silly, really. Localization, that should be built into the system. String conversions, that should definitely be built into CryEngine somewhere. And again, string utilities. String is a multiple offender in this particular case. Enums, again, pretty offensive. And hashes. So it's a lot of sort of core stuff that should really be a part of CryEngine. It should be a lot easier. It should probably all be templated. So I brought in a lot of that, and unfortunately also had to bring in pieces of the item system. Item accessory, most of which is commented out. I've commented out anything that wasn't absolutely needed to make it just compile. Item effect, not much happening there. Some basic item code. Again, lots and lots of this is commented out. Just what is strictly needed to compile and run at the moment is an action. I am going to refactor all the item code at some point, and with 5.4 I'm going to be able to refactor out a lot of the assumptions and dependencies on that item code. So what are the sort of features that Chrysalis has above, say, the C++ templates or Game Zero, and where is it positioned? The idea is that the templates are meant to be very simple learning templates. They're meant to get you started pretty quick, and they do things in a very direct way such that you're not bogged down with the enormity of the information that you need to absorb to actually get started with this development. Chrysalis is pitched midway, like it's meant to be midway between the game SDK horror and the C++ templates, which are very nicely written. So what I've done is I've taken in a lot of that horror, and much of the horror is going to be found in, say, the state machine for the character. So, well, that's pretty simple, but the movement state machine is a little bit nightmarish. So I've taken all that in, and where needed, commented out small sections and just been slowly refactoring through it in such a way that the end result will be that you get a state machine that is very useful for moving your character around and, locomotion, jumping, ladders, all that sort of thing. Everything you'd expect a state machine to do, but without any of the dependencies on the game SDK, which had some pretty hard and fast dependencies on weapons and items, etc. One of the features of Chrysalis is that I've broken a lot of the code down into components suitable for use in an entity component system, such as will be provided when 5.4 releases. Now, a lot of the components are based on existing components within the code. But in some cases, I've made a few little extras, additions, that make it a little bit easier to work with the components. For instance, the geometry component has an iGeometry listener, and that will notify anyone who's listening to it when the geometry itself changes. That doesn't seem particularly important until you realize that, say, flashlight, for instance, here makes use of the geometry. And in fact, I'm expecting most entity components to, if they have a geometry component, to be able to let it know that these geometries change. Now in this case, you can see that it's got a listener. If we go to the definition, it's waiting for the geometry reset to happen, and if so, it has to go and look up the helper position again because it needs to reposition the lighting. And you can see that's a little bit of code there to reposition the light. After picking up where the light term is, which is a helper that you will need on your flashlights if you expect that to work. Version 5.4 is still a few weeks out from release, and I haven't been able to look at the code to see exactly how schematic is going to work and if there's a smarter way to do these sort of things. For the moment, listeners should be smart enough, and should it turn out that schematic's got a really good solution to this, I'll just cut the code across and make it work like that. For now, adding some listeners to a few simple components is not a big deal. If you spend a little time running through the code, you're going to find little gems like the entity effects. That's been ripped straight from Game SDK. I've cleaned up the code where possible and got enough of it working that it works, but it's not great. I'm hoping that either schematic or some part of the new entity component system will make this a little bit cleaner. Since I'm going to probably need part of this for the item and inventory system. Or at the very least I'm going to need it for the snaplock system, which is a system that I'm looking into designing that allows you to just snap pieces of gear together. One of the larger changes that you're going to find between Chrysalis and either Game 0 or C++ templates is the actor and player separation. What I've done is I've taken the concept of an actor and a player and I've just split them into two conceptually different buckets. A player is the person who sits at the keyboard. Now the player is only interested in the keys that they can press, the screen that they can look at, anything that the player directly controls, like the camera. So if we have a look at player code here, you see that my player code has become significantly simpler. If we look at the various things that are under it, it's got not much more than an interface for input, a very simple interface. I might actually remove that. And of course, an input handler, to deal with camera movements, mouse movements, keyboard movements, that sort of thing. You can see here all the different sort of interactions that a player can have with the supposed character. And the code itself for handling all that, 800 lines, it's not very much. And of course, a player needs to see what's on the screen, so I've provided two different cameras and a camera manager. So we've got a first-person camera, that's provided as a component, and an action RPG camera as well, both provided as components, and then a manager, which is able to manage, one or more cameras for flipping between. In this particular case, at the exact moment, we've only got the two cameras so far, but in the long term, it's likely that there'll be, maybe up to 10 different cameras. There'll be cameras for partial animation, full animation, maybe a camera for when you're dead, maybe a pursuit camera for after you're dead and following someone else around. If you look through the game SDK, you'll find that there's probably about 12, maybe 14 different camera setups in there. They're not all needed for an action RPG, and we can get by to start with just the two. But the camera manager's got some important duties. It just sets up a couple of different cameras. Very simple there. You see static cast, acquiring extensions. It used to be done the old way, but I've switched it over to the new way. And then, on an update, well, that's meant to be an update, but update is in flux at the moment. These are still based on the game object instead of the new component system. It can toggle between first and third person. It's not very intelligent. It can just do a couple of little things. You switch camera, log the fact that the camera switched. Now, if we flip towards the actor section of code, the definition within Chrysalis is that an actor is any entity that can work as either a character, a playable character, or a non-playable character, or perhaps a mount, or even a pet. It's anything that can take actions in the game, and those actions should be directed by the player or via AI. The current actor code is based on code lifted from Game SDK and includes code from C Actor as well as C Player. The code between them was pretty mixed together, and what I've done is I've tried to extract everything related to a player and put it into a separate player class. Everything related to an actor has gone into our C Actor class. And there's still a little bit of messed up crap in here because this is all based on game objects still. As you can see, game object extension helper, that's going to go as soon as 5.4 comes out. And there's a whole bunch of things that have been brought in from, well, iSimpleActor, or in fact, let's visit iSimpleActor, or iActor interface as well. So if we go to the definition of that, you see there's all this stuff that has been brought in, and that's all mixed in from the CRYENGINE system, which is not good. That's all going to get deleted, removed, replaced as soon as 5.4 comes out. So the iSimpleActor that we've got here, which is mostly null invocations of all of that. Again, most of that is just going to get trashed. And once 5.4 comes out, Actor will just simply be based on exactly the functionality that we need specifically for an actor to implement. Now, you can see all of this is just cruft. So that's all going to get removed. Right down the bottom, we've got a few other things. Yeah, most of what I've written is just down here. and it's about adding interactivity and various other useful actions to actors. Now, I've made a little bit of progress on pulling action handlers out of the game SDK and pulling them into Chrysalis. Now, most of these are fairly standalone, and although some of them will have some components where they need to talk to the actor itself, for the most part, they're fairly well isolated pieces of code. If we look at locomotion, you can see it's basically a standard action. I'll jump to this definition so you get an idea. This is simply a very simple definition of a T action. There's nothing particularly amazing going on here, and you can see this template code is just being ripped straight from Game SDK again, and that's just a simple piece of template code to allow you to get the user parameters, which is something that's commonly done, but it's done with a different type each time usually. So if we have a look at the actual locomotion code, there's a few fragments that we don't use, and the two fragments we do use. Locomotion is just going to switch us from idle into a move locomotion. It's simply going to look at the actor and say, did you move last frame? Didn't you move last frame? Well, if we're in movement, we're going to use the move fragment, and if we're idling, we're just going to use the idle fragment. There's nothing magic going on there. And then the various tags, it's able to switch between these various tags, so including the posture and the stance, which are just ways of indicating the stance. Are they crawling, crouching, flying, whatever. And then if they're in a posture, and posture really only applies to if they're in a standing stance. It doesn't apply to crawling. You don't have a distracted crawling posture. But posture is another tag that you can apply that can indicate that unaware, suspicious, or ready to pound your ass, for instance. So nothing too exciting going on here. We're just using code that is quite easily available and obvious in Game SDK. Initializing fragments and things, installing, exiting. You come to the exit, the update, and that's where all the hard work's done. And there's not really a lot of hard work. It's just flipping. It's just saying, hey, what stance are you in, actor? And are you crawling? Good. Well, we'll just set a tag for crawling to let the mannequin know that you're crawling. What posture are you in? Again, it's exactly the same thing. Well, we're just going to set that. Which reminds me, those are both the same. They're on the group, I think. Well, maybe they're not. Maybe they're not grouped. They're possibly grouped individually. They're almost certainly grouped individually. I should look that up. And then here's the real guts of it. It's really just 4 lines of code, 5 lines of code. Are we moving? Yes. Then set the move fragment. Are we idle? Set the idle fragment. And then a little bit of textbook code for, I don't want to set fragments if we're not switching them. So I'm just seeing if the fragment changed. If it's changed, should we switch it? Okay, we'll switch it. And that is just boilerplate code from elsewhere saying we should change the root scope. Nothing too amazing going on there. And if you look here, you might believe that I've actually put in the aim pose, looking and look pose actions, and I have certainly put in blank actions for them, but in terms of them working at the moment, probably not. They will work soon enough. I mean, it looks like I've actually copied most of the code across. It might work, it probably doesn't. There's no guarantees on what will happen if you try and run any of that. I've put a little work into an entity sensing or awareness component and an entity interaction component. Now these are 2 components that you can add to any entity to get that particular functionality. So if an entity needs to be aware of other entities in its area, or if it needs to be able to react to interactions or interaction requests from an aware entity, then you can add one or either or even both of these components to that entity. Now, for instance, the entity awareness component is added to most actors or any actor or character, and it allows the character to walk around in an area and be able to query and find out what sort of other entities are near it. It's got several different ways of querying, most of which are fairly quick, and they include just querying like a square area. It's just saying, okay, anything within 5 square meters of me, tell me what they are, what's the entities, and just give me those entities in any order, and I'll do something with that. And it can go all the way down to raycasting or doing a nearest query, like a dot filtered sort of query. So it can sort of bring back the entity that's closest to, say, for instance, where you're looking. Now, those using conjunction, for instance, nope, not that one. Entity awareness. This is a filthy dirty hack, but within the update in front of query, which is a query just to say, all right, what's in front of me? All right, I just want to know what's in front. And if I've got anything in front, it shouldn't really be doing this, but it is for testing purposes. It's just going to go and query whatever entity is in front of me and say, has it got an interactive component? And that's a good thing about components, is we can query if they exist on an entity. If it doesn't exist, that component can't be interacted with. But if it does exist, then it's, for instance, able to go and ask for any verbs that that interactor component can have. Now, at that point, it can display those verbs to the user interface, say in the form of a list, and you could choose simple verbs like interact, touch, open, close, that sort of thing. At the moment, the plan is to provide a simple polymorphic eye interaction. And this will be the basis of any given interaction. It'll provide each of the functions that can be called for any interaction. So interactions will be able to describe themselves, as well as describe themselves to the UI, and set whether enable, disable, that sort of thing. Then specific interactions will derive from that, and in this particular case, you see we've got a very generic interaction, nothing very exciting going to happen there. In that case, it's attached itself to a host, and it's just going to call interact on the host. That's going to be fairly common amongst many of the interactions. See, we've got a DRS interaction here. DRS interaction is to call an interaction on the dynamic response system. And again, it's very similar to the other one. Switch interaction is going to provide the ability to switch on and switch off. These are going to be common for say the flashlight is currently using it, but light switches in general should be able to call this particular interaction. Nothing too exciting happening here. It's just two different interactions are getting called, or three in fact in this case, yes, three. One to allow you to toggle, one to allow you to switch it on definitively, so even if it's on, it should just go on, and the opposite to switch it off. Any item in the system is again be able to be subject to interactions, and the four basic interactions that I'm defining for the moment are that you should be able to inspect an item, pick it up, drop it, or toss it at something. And for each one of those, again, defining an eye interaction that will handle the hard work of those. And in these cases, again, there's a host, and we're simply calling a routine that each host has to implement. So if you want to be able to host eye interactions, then you have to, implement the eye interaction item struct, for instance. Same again for opening and closing items, locking and unlocking items. There was some work on doors, but that's all in flux at the moment. That's pretty much it for the moment. There's a lot more code detail than I was expecting to go through. And of course, there's a lot more code that you can go through if you're interested. As I've said, there's bits and pieces in flux, some is slightly broken, a lot of it is very specifically for testing purposes only, and others are hardwired. But as the project goes on, all of those things will become more and more generic and more able to be used in multiple projects.